Look up at the night sky, and you might assume you are seeing the entire cosmos. You aren't. Since light takes time to travel, there is a hard limit to how far out we can look. We call this bubble the observable universe. The Big Bang happened 13.8 billion years ago, setting a strict stopwatch for light. Logically, the absolute furthest we could see should be a radius of 13.8 billion light-years in any direction. But that math is wrong. The true radius is actually 46.5 billion light-years. We are sitting inside a bubble that is 93 billion light-years across, holding up to 2 trillion galaxies. That is more galaxies than there are grains of sand on Earth's beaches. How could the edge of our vision sit 46.5 billion light-years away when the light has only had 13.8 billion years to reach us? The answer lies in the fabric of space itself. The light really has been traveling for exactly 13.8 billion years, but the space it travels through doesn't sit perfectly still. It expands. Picture the early cosmos. When a distant galaxy first emitted its light toward us, it was located much closer to Earth than it is today. But as that beam of light journeys toward our telescopes, the universe literally grows. The physical distance between us and that distant galaxy stretches, pushing the galaxy massively far away in the opposite direction. Scientists call this new, stretched measurement the co-moving distance. It tells us where that object is located today, 46.5 billion light-years out, rather than where it was when the light first departed. We know this happens because of a phenomenon called redshift. As expanding space pushes galaxies away, it stretches the actual light waves traveling through it, shifting their colors from shorter blue wavelengths into long red and infrared wavelengths. The static edge of the universe is an illusion. To truly map out those boundaries, you need instruments built specifically to catch and decode that ancient, heavily stretched out light. Enter the James Webb Space Telescope. It was designed from the ground up to intercept these invisible infrared signals from the edge of sight. Webb succeeds where earlier observatories struggle because of its sheer scale. Its 6.5-meter golden mirror array acts like a massive bucket, collecting incredibly faint light. At the same time, its instruments are kept freezing. Is the Cosmos Webb Survey. By scanning a patch of sky roughly the size of 3 full moons, astronomers mapped 164,000 deep space galaxies. This visualization shows a highly accurate 3-dimensional map of the cosmic web. You can clearly see the intricate filaments of dark matter and galaxies that grouped together when the universe was only a billion years old. Yet, even Webb hits a wall. Look far enough, and you hit the cosmic microwave background, a wash of radiation emitted just 380,000 years after the Big Bang, before stars even existed. These surveys allow us to physically chart the distribution of matter across the history of the cosmos, reaching back to the first generation of stars. But that 46.5 billion light-year boundary we see right now, it is only a temporary window. This diagram shows what astronomers call the particle horizon, that 46.5 billion light-year edge holding the light that has already reached us. But there is another, much larger boundary, the event horizon. This is the absolute maximum distance from which any light could ever reach us, even billions of years in the future. Current calculations put it at roughly 62 billion light-years. Here is the problem. Dark energy is driving the expansion of space at an accelerating rate. While nothing moves through space faster than light, the expansion of the space itself has no speed limit. At these extreme distances, the gap between us and those galaxies is growing so fast that even a beam of light can no longer bridge the distance. As distant galaxies slip across the event horizon, their light will never be able to catch up to Earth again. Over an unimaginable stretch of time, they will permanently fade to black. We happen to exist in a privileged era where the universe is still lit up and visible to us. Studying the edge of the cosmos is a race to map our neighborhood before the expansion of space hides it from us forever.